Toyota FV2. The famous Japanese company Toyota showed this futuristic single-seat car project in 2014 at the Geneva Motor Show. The main feature of this vehicle is the complete lack of common car details. In other words, the Toyota FV2 doesn't have a steering wheel or pedals. The driver controls this concept car by moving his body forward, backward, left or right. The artificial intelligence technology used in the FV2 connects the driver and the vehicle at a new level. With the help of voice and image recognition, the car can even determine the mood of the driver. The color of the car and the image on the internal displays can be changed depending on the user's preferences, and in addition, the car remembers travel routes and offers appropriate directions, also analyzing the driver's skills of the owner to assist him or her while driving. ASAP. This device, designed and created with CGI technology by 4 students of a design college, is a hybrid vehicle that combines elements of a helicopter and a small plane. In order to fly, the helicopter needs a usual helipad, and once in the air, the triple chassis automatically hides inside the body. In airplane mode, ASAP can reach speeds of up to 220 miles per hour, thanks to its streamlined shape and additional propellers on the wings. Another nice bonus is the cleverly designed cockpit, which has, for example, a maximized viewing angle thanks to a series of digital panels located on the windows. Volkswagen's Cedric. This unmanned taxi can be called by pressing a button on a special key holder. The car will arrive and automatically take its new client to the right destination. The taxi is designed for 4 people who sit in the cabin on 2 couches facing each other. It is also worth noting that Cedric is not equipped with a steering wheel and pedals, so you need to set the route and control the onboard systems with your voice. The unmanned Volkswagen moves using a 130 horsepower electric motor on the rear axle, while the lithium-ion batteries placed under the floor let you travel for up to 250 miles. Renault Float. Chinese student Yu Chen Tsai won a competition organized by Renault thanks to this car design. According to the young designer, in the future the ball-shaped float vehicles will fly above the ground using magnetic levitation. A sphere resembling a soap bubble can carry 1 or 2 passengers, and you can call this unusual unmanned vehicle with a special mobile application. 2 or more of these cars can travel together using additional external magnetic belts, while the passengers will be able to communicate with each other using special audio-visual systems. The degree of transparency of the surface of the sphere, which resembles a durable glass, can be changed by the user at will in order to get more exciting and unforgettable impressions of the ride in this unusual transport. Smart Vision EQ42. Designed as a part of the presentation of the Smart 2030 generation, this car project is fully electric, autonomous, and is designed exclusively for future car-sharing systems. The Vision EQ has no control interface, that is, no steering wheel or pedals. Inside and outside of this vehicle, you'll see a lot of displays and indicators that allow the car to communicate with passengers and pedestrians. When the car is free, it will independently travel to the nearest station to charge its 30 kWh battery. The model is equipped with a 24-inch screen that displays all the information, including navigation, video, and images. The seats are designed as a bench covered with a white eco leather and a retractable central armrest, under which there is room for a small bit of luggage. Airbus flying car. Airbus presented its idea for an air taxi, developed along with the design team of Ital Design. The vehicle has a modular design that allows it to move both in the air and on roads like a normal car. The passenger capsule pop-up system can be called up on demand using the mobile application of any online taxi system. The platform, based on artificial intelligence, takes into account the preferences of each particular client and finds the optimal route for his or her trip. Another component of the car is a completely virtual environment that will interact with the user and respond to their actions or movements. The aircraft is 8.5 feet long and its body is made of heavy-duty carbon fiber. The maximum speed of the Aerotax Airbus is 150 miles per hour. Mini Vision Next 100. One of the key elements of this vehicle is the specially designed instrument panel Cooperizer. The resulting colors and patterns design a multifaceted intelligent digital system, which can create an optimal microenvironment for each driver. Depending on the mood and desire of the user, as well as the traffic situation, Vision Next 100 is able to choose the roof color and the interior lighting mode, while adjusting the internal entertainment functions and determining the necessary information for the trip, transmitted to the navigation system. In addition, the interactive windshield shows an excellent view of the road, and the augmented reality system displays the route and the optimal trajectory. The vehicle can operate autonomously, but it also comes with a steering wheel. The Bee. The technological group Continental introduced the concept of an autonomous electric vehicle for the city for 1 or 2 passengers. According to the developers, the Bee can be called using your smartphone. The vehicle is small in size as it consists of 4 wheels, a windshield, a translucent roof, and transparent door panels, which also serve as a display for information output. The compact concept car is equipped with an electric motor that provides a maximum range of 220 miles and a speed of 38 miles per hour. Aeromobil 3.0. This project from the Slovak company Aeromobil is a flying machine that has folding wings, a parachute rescue system, and an autopilot. The Rotax 912 motor allows the vehicle to reach 100 miles per hour on the highway, but in the sky, it can reach 125 miles per hour. On the highway, the Aeromobil 3.0 spends 8 litres of fuel per 60 miles, and in the air, about 15 litres per hour. The car uses conventional gasoline. On Earth, it can travel 550 miles, but while in aircraft mode, it can fly for 430. The vehicle also has an airmobile system for wing adjustment, so it just needs a few hundred feet for takeoff. E-Ring Go. Designer Mohamed Ghazel created a 3-wheeled car project. It stands out from other vehicles by the fact that the wheels are located not in the form of a triangle, but in a row. According to the designer, the car will use mainly the central wheel, which will control any movement. The other wheels are used only if there is 1 instead of 2 people in the car, which is the ideal number to keep the vehicle balanced. In this case, the wheels simply rotate at different speeds. They're also needed in order to make sharp turns. In addition, there is 1 small wheel on each side of the E-Ring Go. They are used for parking or to end.
Pizza. While many restaurants in the world specialize in making handmade pizza, big food companies use automatic processing to create chocolate. To begin the production of chocolate, you need chocolate beans, which are ground and converted into a homogeneous mass. A high temperature and a special rate of mixing give the chocolate its distinctive consistency. and then cocoa butter and flavors are added. The resulting chocolate mass is distributed into molds using a standard automatic dispenser and shaken manually to remove all possible bubbles. After the finished tiles are frozen, they're placed on a conveyor belt and packed to be sent to stores. Coca-Cola. Despite the fact that Coke's final and accurate recipe is kept a secret, monitoring the process of bottling the drink is quite interesting. The bottles arrive to the plant directly from the bottle fabric, but they're washed one more time to destroy any harmful substances. Meanwhile, in a separate container, the workers mix purified water, which represents 86% of the drink, with a special infusion, and then concentrated sugar syrup is added. After that, the bottles are cleaned with gas and placed in a special device that then fills them with Coke. Potato chips. During the first stage of production, potatoes are washed in a special drum. Once the vegetables are peeled, they're sent through a dispenser into another machine, which cuts the potatoes into thin slices. To remove the excess of moisture, they are placed in a centrifuge and then fried in oil. To give the chips a special taste, manufacturers use a mixture of spices and flavors that are evenly distributed over the potato slices. Dale's Raw Protein Bars. For the production of protein bars, the mix, whose composition remains unknown, is placed manually in a small mixer, where it's mixed together with special syrup. The resulting product is cut in the form of little bricks, covered with chocolate glaze, then packed and placed in boxes. Peanut butter. Once the peanuts are out of the shell, they undergo one more stage of cleansing to get rid of the husks. They're then ground, mixed with other ingredients such as salt and sugar, and placed in a large container with a mixer at a stable, warm temperature. This is necessary to prevent the solidification of the mass ahead of time. The final and ready-to-eat peanut butter is placed in thermally treated jars. Ketchup. The main ingredient of ketchup is tomato paste, which arrives to the factory in vacuum packages to preserve freshness and taste. With the help of a special pump, the mass is placed in a special container and mixed with other ingredients such as salt, sugar substitute, vinegar, and more. On the next step of production, the plastic bottles pass through a special cooling system before they're filled with the ketchup. The machine fills 8 bottles at a time, and the manufacturer has to check 1 bottle from each lot. After the ketchup is in the bottles, the labels are glued to it. Croissant. On the first page of the fully automated process of baking croissants, the mechanically mixed dough is pressed down and sent to a special conveyor. A special mechanism rolls the mass to create a thin layer of dough, and any excess is removed with the help of two cutting elements located along the edges of the conveyor. Then, the dough is cut into triangles which are twisted to create the croissants. Each croissant is placed in a separate cavity and baked. It's also noteworthy that the croissants are filled automatically, that is, through a series of dispensers, which penetrate the finished donuts. Unlike other sweets made in big factories, the production of donuts requires much more human intervention. This is due to the gentle consistency of the dough, which can easily crumple or get damaged by the machines. Therefore, after placing the dough in the molds, any excess is removed manually, and the workers transport the donuts directly to a special frying device. The fried donuts are placed on a special conveyor and sent to the glaze dispenser section, and then into a small drum to evenly distribute the powder. Ice cream. Machines used in the production of ice cream are as different as the different types of ice cream they create. For example, an Eskimo pie fixed on a stick is not placed in a container with chocolate, but on the contrary, stays in place while the chocolate rises to it. Another sort of ice cream is dipped in glaze only on one side. The initial stages of production, such as placing the stick inside the ice cream, as well as distributing the sweet mix into molds, is also very interesting.